There is a story about the philosopher Ludwig Wittgenstein that always caught my imagination. Somebody commented to him on how stupid medieval Europeans before Copernicus must have been if they could look up at the sky and think that the sun orbited the Earth. Anyone with a modicum of common sense could tell that it was the opposite way around. Wittgenstein is reported to have responded, "I agree, but I wonder what it would look like if the sun had been circling the Earth." Of course, it would look the same. And those medieval Europeans were just as sure the sun orbited the Earth that we are certain that the Earth orbits the sun today. What took us from one place to the other required as much imagination as it did math and science. How do you imagine the shape of the universe? This may help. Imagine you are on a spaceship, which, for argument's sake, has an inexhaustible amount of fuel. If you traveled in a straight line across the universe, eventually you would end up back at your starting point. How can that be? According to Albert Einstein and his theory of relativity, space is curved. For an analogy, imagine you are on a sailing ship on a planet entirely covered by water. You sail your ship in a straight line, yet eventually, if you stay on course, you end up back at your starting point. It seems to you as though you're going straight, yet actually you're moving in a circle. The shape of our universe may be akin to some sort of hypersphere that radiates out into 4 dimensions. But if the universe contains us, what then contains the universe? Most of us believe there is only one universe. Perhaps it can be said that's just common sense. But outside our universe, there may be a multitude of other universes born out of a Big Bang that created multiple dimensions as well. The concept of the multiverse is an idea supported by Sir Martin Rees, former director of Cambridge University's Institute of Astronomy and England's Astronomer Royal, as well as many other cosmologists. There have been recent experiments in quantum teleportation, where scientists have succeeded in destroying bits of light in one place, then reconstructing them several feet from their original location. If you're thinking I'm talking about something like the transporter from Star Trek, you're right. In 1997, Anton Zeilinger and his colleagues at the University of Innsbruck in Austria performed the experiment, whose results were duplicated by another research group in Rome, Italy the same year. Zeilinger reports that soon we'll be able to transport atoms and whole molecules. If you don't quite comprehend the phenomenon, don't worry. Even Zeilinger says he doesn't fully understand it himself. This experiment demonstrates some of the principles behind quantum mechanics, where any number of possible outcomes can result from one particular event. Einstein was disturbed at the idea that quantum physics could exist. As he said, God does not play dice. However, if the quantum teleportation experiments do demonstrate the existence of quantum laws of nature at work in the universe, then the multiverse may very well be real. Astronomers once said that ether, an invisible and undetectable substance, held our universe together. Today, astronomers suggest that something called dark matter, an invisible and undetectable substance, must exist in order to keep galaxies from flying apart. Have our ideas changed, or just our terminology? One wonders if we are any closer to the truth in our time than Aristotle was in his. When Galileo turned his telescope up to the night sky, he saw countless stars where before the naked eye only saw the blackness of the void. In 1775, Immanuel Kant speculated that the fuzzy patches of light he saw through his telescope were other galaxies, perhaps just island universes, to use his own words. Mainstream astronomy rejected the idea of other galaxies, and the idea remained quite controversial until confirmation came in 1924, when our technology was sufficiently advanced to detect them. Until then, most people thought the universe to be limited to just our own galaxy. We are eternally at that point where Galileo turned his telescope up to reveal what was always present but never proven until our imagination compelled us to ask what lay beyond the limits of our knowledge.